Hello everyone, my name is Manikant and my teammates are Amit, Dhanush and Naveen. And now we are going to give presentation on LexiFlow engine. The visualizer uses the following completely distant source layout targeting branch computations. This isolates your data transformations entirely from identical templates. Uh, Lexical analysis. Our group is excited to present our project LexiFlow, an advanced web-based structural compiler visualizer engine. When a modern AI coding assistants or advanced compilers receive a block of source code, they don't just treat it as a massive string of a random text. They must dissect it deeply to comprehend its layout, logic, and intent. Our single page web application visually opens up the hidden pipeline using interactive high fidelity data models. I am responsible for the first stage of this pipeline. Lexical analysis is also known as tokenization. As seen on our live interface, the source text stream is parsed sequentially using regular expression matches modeled after deterministic finite automata from automata theory. The engine strips out the meaningless white spaces and bends character chunks into discrete elements called tokens. Each token is assigned as a hard classification, such as zeroed keyword, data type, identifier, uh, or literal value. This creates a flat token sequence stream that acts as the foundational layout for all subsequent steps. Now I will pass it to member 2 to explain how we structure these tokens.
Now I am going to explain. I'm going to share the live application screen and walk you through the structural blueprint of our code. And the action is click compile trace and then activate the syntax tree tab. Once member first lexical stream is completed, the tokens are fed directly into hierarchical structural compiler parsers. To build the abstract syntax tree, the AST strips away redundant punctuation like semicolons and brackets, the focusing purely on nested hierarchy of the logic. Looking at our graph visualization, you can see the root node is the translation unit branching downward to the function main. From the our expression blocks split into variable declarations and statement vectors. This structure tells the compiler exactly what components exist in the code before figuring out how they execute. Next, Naveen will be explained.
I am Navin. I am going to explain the once the program structures are mapped out, we need to analyze execution dynamics. I will covering the next two visual layers: control flow and data flow. Action active control flow tab. The control flow graph CFG charts out every single physical path. The execution can take our nodes represent isolated execution statement blocks, while the directional arrow vectors display runtime conditions. Notice our conditional if x is greater than or equal to y structure creates a diamond branch split automatically rendering a green path for the true branch mutation and red path for the false branch execution before merging back at the output print statement. Action activate data dependencies tab. Right next to it, we have the data flow graph DFG. While the CFG tracks the path of execution, the DFG tracks the path of values. It traces def use change mapping exactly where variables like x, y, and z are initialized, where their values are read as inputs by mathematical operators, and where they are modified. This layer is crucial for modern software security scanning. Now, continue by Amit.
Myself, Amit, I'm going to explain property graph and AI assistant link. To conclude our pipeline, we look at the final tab, the code property graph, CPG. The CPG Unlimited Fusion Stack, it merges the structural hierarchy of the AST AST of AST. The execution pathway of CFG, the variable values DFG into single unified graph database workplace. This exactly where our project connect the directly to the modern AI coding assistants. We when stage of the art developer tools analyze a complex software responsibility the index the code base using a structural graph precisely like this CPG by querying the graph nodes and AI can immediately map out hidden software dependencies and safely generate the code modification without causing bugs. To summarize, our group built this entire advanced visualizer app natively in HTML, Tailwind CSS, and Wiz.js. It operates instantly in a single browser tab with zero external setup, demonstrating how traditional compiler design principles power to modern intelligence tools we use every single day. Thank you. And